everyone. My name is Sandra Kim, IA's Professional Development Director, and I want to welcome you to the Manufacture Series webinars. Today's webinar is titled Filtration Technologies, Filtration Spectrum and Applications in Landscape Irrigation, and is sponsored by Amiyad Water Systems. Amiyad has been mastering filtration technology, developing and marketing filtration solutions for agricultural and industrial use for over 57 years. For more information, visit their website at www.amiyad.com. Now, I have just a few housekeeping notes before we get started with today's webinar. This session will be recorded and all microphones will be muted. This webinar is worth 1 CEU. You can enter it on the Submit CEUs webpage under the Certification tab at the IA website at irrigation.org. A question and answer session will be held at the end of the webinar. If you have any questions, please type them into the question box on your screen. The presenter will address them at the end of the session. Our speaker today is Ron Kraus. Ron is the National Landscape and Greenhouse Team Lead at Amiyad Water Systems. Without further ado, I'll turn it over to Ron.
Great, thanks, Sandra. I'm going to take myself off the camera so that you guys can see the slide and pay attention to the presentation at whole. And then I'll come back on the camera at the end when we do the question and answers, and we'll spend some time going through those questions and answers. And we'll address them as we can. So without all that, we'll go into the presentation. As Sandra said, I'm Ron Kraus. I'm with Amiyad Water Systems. I've been with them for over a year now, working in water filtration and the landscape irrigation. I have 35 years in the industry and spent quite of that time dealing with irrigation and designing and building systems throughout most of the Western Hemisphere in the United States. And so it's been a pleasure of mine to work in this industry for so long and to continue to work in this industry. As I said, I came on board with Amiyad Water Systems about a year and a bit ago. Amiyad Water Systems is a world leader in the water treatment and filtration solutions. They have been established in 1962. We have 15 subsidiaries throughout the world, so we're a global company, which is great because it gives us the resources and the ability to achieve great things in water filtration. So we're going to kind of jump right into filtration and talk a little bit about why filtration and what filtration is and how filtration can help us in the landscape world. In order to understand filtration, we need to understand what we're filtering and how it operates. Filtration is suspended solids removal from water. The process of removing a solid particle from liquid by forcing them through a porous medium. Our automatic filtration solutions include a variety of products, including manual, semi-automatic, and automatic filters, which utilize our 4 technologies, which we'll talk about throughout this presentation. Particle filtration, particles, what are they? You know, particle size, that's all dictates what we need to do in filtration. So the particle size affects its ability to be separated out of the water and constitutes a significant factor when selecting the appropriate filter measure. So as you can see over on the right-hand side, to give a little bit of understanding with filtration and the particle sizing, sea sand grain is about a 90 micron. And we'll talk a little bit more about the definition of what a micron is and why that's important and significant in filtration terminology. Particle type. In water, there are various types of particles. Those we want to separate out of the water, we will call contaminants throughout the presentation and throughout our discussions. The contaminants are divided into three main groups. The first one being mineral contaminants, sand, silt, debris, iron, bacteria, or sorry, not bacteria. Then we jump on to the biological contaminants, which is where bacteria, algae, and those things come in. And then we have our dissolved solids. So the effects of non-filtration is clogging. And why is clogging or debris in our irrigation systems important to know and understand? Well, in order to understand that, we need to understand our emission devices and the things that we're trying to protect. Severe clogging affects our distribution uniformity, the term used to define a system's efficiency and performance. For every 10% decrease in distribution uniformity is calculated as 30% wasted water. And this is important in our world with water being such a scarce commodity for us. And then especially when we're discussing emission devices, our industry is moving to lower application rate emission devices, precision nozzling, lower, smaller orifices on our drip systems, makes it so that we have a finer diameter of a hole that allows our water to emit through, which can cause issue if we have debris and contaminants in our water. This will drive up maintenance costs, not only labor in terms of cleaning those nozzles or the drip systems, but all in all replacement of those emission devices if they get clogged up and are bad. With those items being clogged or challenging, it's going to be an effect on our landscape, our plant material, and last but not least, we would lose costly plant material to lack of water. And again, it's all a decrease in efficiency in our systems. So the main defense against clogging is mechanical filtration. The filter element is trapping and removing suspended solids from the water, not dissolved minerals like salts and those things, but the dissolved solids or the suspended solids. So why again is this important? Well, it protects our emission devices. It's like an insurance policy. We put in our filters and we capture those things that are going to cause havoc in our systems. And this will help maintain our uniformity and our distribution of our water throughout our irrigation. Part of filtration, we have to understand the water sources that we're dealing with. In the US, we have quite a few water sources that we may see throughout the different areas. And some are more prevalent than others, and some are less than others. Many of us are familiar with municipal water, potable, culinary water. This is generally good, clean water that comes through because it's filtered or cleaned at the water districts before it's supplied to you. But we pay for that. It's an expensive resource that comes to our homes and to our businesses. This still requires some sort of filtration because there's still some suspended solids that travel in that water. And if the instance comes about where you have a damage in a line or something like that where the solids can get into your line, it's going to wreak havoc on your irrigation system downstream. Surface water is becoming, or well, it's been used for many, many years, but it's becoming more and more readily used as it's available for us. This water is generally poor in quality in terms of debris, suspended solids, algae, and those items that cause havoc on our irrigation systems. It's a lower cost, but it's going to come with an expense to filter. Well water, many of us are familiar with well water. This can be good to average. Not all properties have this option, but it still has sand, silts, and debris within that water. Gray water is reused from discharge of property. It's going to be dirty, and it's going to need some filtration in order to manage it. And it's going to filter out where you're going to deal with sand, silts, organic hair, fibers, and debris. Rainwater is becoming more and more popular as we see stormwater retention basins, cisterns on properties and projects where they're capturing the water and reusing it. This is very, very common in Bermuda. All of the rooftops are actually designed to capture the water, and they're stored in cisterns in a basement and reused. But filtration is required in order to have that water without debris in it. Recycled water is another one that is really prevalent and becoming more and more common throughout the United States. Its initial setup is expensive, but long term it has its rewards, but it is dirty water. I visited a site last week that had extensively dirty water and is in dire need of filtration in order to protect the emission devices downstream. All right, so principles of water filtration. We're going to talk about the terminology, the things that come up that you may or may not understand, but maybe we can address those and help resolve concerns so that we understand filtration and what it needs to do for us. First things first, what is a micron? Well, a micron describes the 3D diameter size of particles. The micron is defined, 1 micron is equal to 0.001 millimeter, a little more than 1/25,000th of an inch. The human eye can see 40 microns, just to give you an example. So, and then down in the left corner there, you can see that the sands are between 100 to 2,000 micron in size, just to give you a little bit of an understanding of that. But it's a 3D image or 3D symbol for micron. Micron is important now that we discuss filtration size. Declared filtration size is based on micron, our results of performance tests done by an official lab. A filter size will be determined based on it capturing or restraining 85% of the particles in that size won't be able to go through the filter. And this is done by a third-party lab, an IFTS. Amiad's filtration spectrum by technology is anywhere from 1 micron to 10,000 microns. So pretty much if you have a filter need, we have a filter that can solve the problem. There are multiple different technologies for filtration. There is the discs, which is widely known in the landscape. Screens, again, widely known in the landscape. Media, which is known more in the ag, and separators, also known more in the ag and industrial world. We're going to focus more on disc and screen filters and talk a little bit more in depth on screen filters in this presentation. I just wanted to give you guys a little bit of a visualization of what filtration results. Plus, I like to be candid about things. This is like the Lysol commercial that you see when you spray it on and it gets 99.9% of all bacteria. That picture just represents how this works. Filtration results. So before, and this is 500 micron, and after. So you can see how much debris comes after the filter. If you could imagine limiting that down and not having the larger debris going through your system and clogging up your heads and your nozzles and your drip systems. This is another picture of insufficient filtration. We don't really want to see dirty water coming out the lines, because as you can imagine, every one of those clumps or chunks is not going to make it through your drip system or your precision nozzles or your rotator nozzles and things. All right, micron versus mesh. Everybody knows about mesh. Micron is not a new term, not a new technology. It's actually the way things are measured in a more accurate setting for filtration. So the definition of mesh is basically how many wires or fabric lines there are in 1 linear inch of screen. This definition actually taken from the garment industry. So it came from, where our shirts and jeans were made. How many linear or how many lines of garment or fabric is in 1 inch of screen area? And in this filter world, it's screens or it's wire. A micron is actually the dimension of the opening of the screen between the wires. So you can see the difference between the terminology and the measurements. And obviously, as you go up in mesh, you go down in micron. So in the landscape world, we're probably familiar with the 70 to 80 to 100 mesh. And if you convert that over to micron, it's a 200 to 149 microns. But again, you can see how the measurement of mesh doesn't take into consideration the thickness of that wire. It only takes into consideration how many of those wires are in that inch. So you can see how that term can really have a large variable in there. And this is why we lean on the word micron and use that in our terminology. All right, filtration degree definitions. There's 2 definitions here that we need to discuss. One is nominal and absolute. Absolute filtration rating is all particle larger than a specific diameter are removed 100%. Nominal is most particles larger than specific diameter are removed 85 to 99%. Again, the Lysol commercial where you have a percent still sliding through. So filtration degree definition in different screens. You can see on the left, a perforated screen is going to only have the rating of an absolute. The wedge wire, on the other hand, is going to have a nominal or vertically and an absolute side to side. Weave wire will have a nominal and an absolute. All of this talk comes into play when we talk about effective filtration area. When we look at the area of a filter medium which is exposed to the flow of participants in the filtration process, the effective area of the amide multi-layer screen element is 95% its total area. So that means that 95% of our screen area is part of the effective filtration area. We'll talk about why that's important when we get down to our manual filters and how that affects that in terms of flow, water use, and cleaning the filter. Again, filtration velocity equals the flow rate and effective filtration area. Screen filters, cleaning cycles. So we have 3 different cleaning cycles or styles of cleaning on screen filters. There's the manual clean, which is physically remove the filter element, scrub it and wash it and clean it out and put it back together. There's the back flush, where you'll have a valve on the bottom of the filter and you can open it up and it washes out most or any of particulates it can get out of there. And then you have the focused backflush, which is a reverse water flow through nozzles concentrating cleaning to less than 1 square inch, which increases suction force. So when we talk about these, compare the levels of technology, a manual, semi-automatic, or a fully automatic, we want to compare those technologies with the type of water that we have and how that comes into play with what we would select for our project. Water quality is probably our primary consideration when it comes to selecting whether you would use a manual, semi-automatic, or fully automatic system. If you have decent water, a manual system could work, meaning that you're not going to have to clean that only but maybe once every few months, and it's accessible, easy to get to, and it's not a huge ordeal to clean it. On the other hand, if you have good to average water and you don't want to spend your days cleaning a filter, semi-automatic is your choice, because you can still access the filter, clean it without disrupting the system, and you don't have to take it completely apart to do so. Now, on the other hand, if accessibility to the filter is difficult, if you have average to poor water, you're better looking at a fully automatic system that will do the cleaning for you, and it won't take your labor time to do that. And again, we've talked about our water supplies in terms of whether good, poor, average, or very poor. And we have a list of them based on what we have determined throughout the nation. All right, considerations for sizing a filter, and this isn't necessarily sizing in terms of pipe size. This is in terms of sizing as based on flow size and what your irrigation demands are. Number one is your flow rate, your gallons per minute. How many gallons per minute you're flowing through your main line or your system that we are going to put a filter on. Number two, your static and dynamic water pressure. This is critical. We want to know this in order to be able to determine what filter will work best in that application. Number three, your water source, whether it's average, poor, great. If we understand this, we can find a filter that will fit that project. And then what are you protecting? That's a big question. You know, if you're most irrigation manufacturers, nozzles, heads, drip systems have a recommended micron filtration degree that they are going to put on their packaging or on their spec sheets that will help you to know what you want a filter to. And utilizing that information will help you be able to select your filter. Generally speaking, with Amiad, you will find that there are probably 2 to 3 to 4 different filters that we could recommend to use on any given project, and they'll be successful. So let's go through some of our filter types and how they can help us and how they apply to our projects. Manually operated filters. So there's pros and cons to any kind of filter that you're going to purchase. One of the pros of a manually operated filter is its low cost, simple installation and maintenance. Some manufacturers offer a high quality 316L stainless steel screen. Typically the sizing on these or the material used is a propylene housing for corrosion resistance. Common sizes for a manual filter is going to be 3/4 inch to 3 inch. The cons for a manual filter are that it's time consuming to clean the manual filter. It takes time to put it back together, and your system has to be off during that process. So, you know, when you're dealing with a manual filter, you want to consider all those options that you're going to see in your irrigation in your landscape. Again, accessibility is a big one. If you can't get to your filter often enough to clean it, it's going to clog up and you're going to have a distribution uniformity issue or an efficiency issue in your irrigation system downstream. Amiad tagline is the manual plastic filter that we have for this application. All of our screens are high quality 316L stainless steel. This is important to know because they're not just coated steel, stainless steel, they're through steel, and they It's for corrosion and protection and strength. They're all propylene housing for corrosion resistance. This is a great filter for landscape application. The available sizes are 3/4 inch to 3 inch, and it's rated to 116 PSI. This is a low-cost option, and it's a great product for your typical landscape application if you need a manual filter that you can get to and clean in a timely manner based on the water quality. All right, I put this screen here for a reason. There's some important things to discuss here. We talked about effective filter area, and we talked about the square or the dimensions of the filter and how that relates to the importance of a filter and timeline of cleaning. This is how this becomes important for us. When you double the surface area of a filter element, you quadruple the time between cleaning. I want that to be real clear. When you double the surface area of a filter element, you quadruple the time between cleaning. Most of the screen filters you will see in the industry are about 200 to 250% less screen area than our screen areas on the Amiad tagline on any general filter that we have. Again, when you think about that and you double that size, you decrease the time you clean by 4 times. So just kind of think about that in terms of when you're going out and putting in a manual filter and you think, well, if I'm going to have to clean this with the dirty water and the screen area is this, and I'm going to have to clean it every month, if you put one of ours in, you would only have to clean it every 4 months. So it's important to remember that stuff when you're purchasing filters and putting filters in a project. Our Amiad manual plastic is a very similar product to the tagline, but its PSI rating is a little higher. It's a little bit, its durable's built more for the commercial side or small ag. It does again have the 316L stainless steel screen. It's a propylene housing. It's small ag to landscape applications. Again, 3/4 inch to 3 inch, rated to 150 PSI. On many of these, you can do screen or disc elements. All right, semi-automatic filters. Why would you use one? Well, the pros are they're a low-cost option. They're minimal cost and they're simple installation to put in and somewhat simple maintenance. Some manufacturers do offer the high-quality 316L stainless steel screen, the propylene housing or steel housing. Typical sizes on this are 2 inch to 8 inch. They have clogging indicators, or some have clogging indicators. It can be cleaned without interrupting the irrigation cycle. This is important to remember. You can clean these without turning off the irrigation downstream. Whereas the manual, you have to shut the system down, open it up to clean it. It requires a low pressure for proper cleaning. That's why you can clean it while it's in operation. So the cons are it does require constant supervision. Somebody has to go out and physically look at it and see if the clogging indicators popped up or if it needs to be cleaned and the system's not functioning properly. You still have to manually go out there and turn the crank. It's kind of like having the difference between a automatic window and a cranked window from the years gone by. Many of us will remember those days and some of us probably won't. So it's much like that. In the Amiad semi-automatic filter line, we have the 316 stainless steel. These work great in small ag to landscape applications. Available sizes in plastic is 2 to 3 inch. In steel is 2 to 8 inch. They have clogging indicators on them. and can be cleaned without interrupting the cycle. And ours require less than 35 psi for proper cleaning. All right, we're going to talk a little bit about self-cleaning, how that works. I have a video that I want to show you guys about it's the Mini Sigma series, and it will show you how self-cleaning works and give you a little bit of information about the Mini Sigma, and then we'll talk about how this applies to projects and what we can do with it. And I'm going to walk you through the video so that you can understand what we're going through and why we would like the Mini Sigma.
Amion's Mini Sigma filter.
Okay, so as it's mentioning, it's low-cost operation for this filter. This filter has a couple different installation styles that you can do, either an angle version like this or a online version where it lays flat. It's a very compact, small footprint of a filter. So fitting it into a landscape application is ideal. If you think about it, it doesn't take up much more space than your typical backflow preventer. There are strong boxes and cages that are built specifically for this. And as you can see, there's multiple installation applications that you can do with this filter. This here you're seeing is the coarse screen. It's the pre-screen to the filter that's going to collect all the big debris before it goes up through. And that coarse screen can be clogged or blocked up 85% and it'll still flow properly. This is what I was talking about with the self-cleaning inside. This is the backflush valve that will open, allowing that turbine to spin, which pulls the suction through the suction scanners, moving that around and up, sucking and cleaning all the debris off of the filter screen. This all happens in a matter of about 10 to 15 seconds. This filter is fully automated. It runs off 4 AA batteries. A Bluetooth control, the ADIP, allows you to operate the system as needed off of this. You can see the inlet and outlet pressure right there in the palm of your hand. You can flush it. You can also get history and data that you can submit back to or email back to yourself so you can review it and understand what's going on with your filter. So really a self-contained filter that does everything you need for it. No wiring needed, nothing needed to be able to install this filter other than the inlet and outlet. All right, automatic filter. So what are our pros and cons for having an automatic filter? Well, pros are is we don't have to go out there and clean a filter. That's number one. And it can be cleaned without interrupting the irrigation. So that's really important to understand that this system automatically does itself and flushes itself, but won't interrupt your irrigation cycle. So your system can fully running and fully operational. The other pros is that a lot of them have the 316L stainless steel. You can get them in propylene or steel housing. 2 to 20 inch is what you'll see in the industry for filter sizing. They're fully automatic. They're consistent performance of the irrigation system. Some of them offer a wireless control, not many, but some. There's flexibility of installation is one of the great pros with an automatic filter. The cons are some require high minimum pressure to sustain cleaning cycle, so they need a little bit of pressure to keep them going. And then some require a long flushing cycle, which has a high discharge of water. So what you guys saw was a series. You saw the Mini Sigma. There's a series called the Sigma screen filters, which is the Mini is part of that series. This is our fully automatic propylene housing filters. All of ours offer the 316L stainless steel screen. They manage good to poor water quality. They're great for small to medium ag and landscape. We see them in pumps, housing, cisterns, recycled water, you name it, they're going in. Available sizes 2, 3, 4, 6, 8 inch in the black plastic. They have the ADIP controller, all of ours do, that is fully operational off of 4 AA batteries. And again, it can be cleaned without interrupting your cycle. It has a 22 PSI proper cleaning, requires that. And there's 2 different versions, again, the online or the angle model. The Mini Sigma is our primary one that we look in the landscape. Between that and the Filtamat, which is a steel housing. These filters are great for landscape application, great for dirty water, for pressurized irrigation, for recycled water. And again, we have details and CAD drawings that work with all of these filters and can be utilized throughout all the states. Okay, so we're going to go back to that same question that we talked about. What's the best filter for my application? Manual filters. If your water quality does not clog the screen in a very short time, and or if you have the manpower to clean the filter, then a manual filter will work for you. A semi-automatic filter is great if the manual filter is just requiring too much and your water quality is average. An automatic filter works great for those properties and or maintenance contracts or things like that that people will come across where they're not going to be on the property every day and they need something to be automatic. They need to be able to have it so the system is functioning fully and capable of what it's able to do for the efficiency of the system. So that's really the nuts and bolts of it in terms of what you would choose for your application and how it would benefit your property and your project. Every project's going to be a little different. I have a few pictures of some installations and some different things that have been done on various projects. And then we'll jump into some question and answers and kind of run through some things with that. But here's some installations that have been done. These are installation applications for some manual and semi-automatic filters. Generally speaking, these filters will be installed above ground. They can be installed below ground. Many of the manual filters and some of the semi-automatics. However, the complexity of operation of those filters will depend upon whether you would put it in the ground or not. You would need a jumbo box to put some of these in the ground. But keep in mind, cleaning those becomes difficult the more you compact them into the ground. And they do need some atmospheric break between them so that you can allow some of that water to flow out properly so you can get a good cleaning on them. So generally speaking, we suggest and encourage people to install them above ground in a cage or a protected area, something like that. But if your application does require it to be in ground, it's something that can be done. Here's a Mini Sigma that was put in. It's actually in like a farmhouse and it's utilized to protect drip. It's pumping 160 GPM at 100 micron. This is an angle installation. This is the Filtamat. It's the same theory and same concept as the Mini Sigma. It is laid in a horizontal. On the Filtamats, generally speaking, they're installed like this. This would be it's a 200 micron. and it's probably, I wouldn't want to say it's, I don't know, 400 to 500 GPM, but I'm not 100% sure. This is also a Filtamat. It's very similar type of application and use as the Mini Sigma, except for in a bell style. So it's a little bit more compact. This is for your higher pressures. It's going to handle a little bit higher PSI and a little bit more GPM than what the Mini Sigma would do. Again, another Filtamat that's installed. This is on a landscape irrigation for a junior high school. And most of these are on like a pressurized irrigation. So the water's pretty dirty. Here's one for a city park. Okay, well, so I wanted to be able to give you guys some contact information of our different regions and different people that you can communicate with. If you have questions or needs or anything that comes up in your area, these are the individuals that are, they're familiar with your region, what you're dealing with, and can be a great resource for you with anything regarding filtration, with amide filtration. If you jot their name down and number down, give them a holler if you have questions about filtration in your area, or even if you want to learn more about filtration. We do have some more, we could share with you some of the interactive videos that we have and different things like that. It's a great resource for you. And then this is my contact information. If you missed anything on the last few pages, or if you missed anything on the contact, who you should be contacting and where they're at, take my number down, my email address, shoot me an email. I'll help you and resource you and guide you to anybody that you may need for resources. And that's pretty much it for the presentation. I appreciate you guys joining. We got a little bit of time. We got some time for some questions and answers in regards to that. And I'll turn the time over to Sandra and let her moderate that.
Great. If you would, you could turn on your camera during the Q&A session. Thank you.
Yep.
I have quite a few questions. The first one is, how often should you rotate out your filters, and how expensive can that become?
Okay, so how often would you rotate? I'm assuming that they mean that how often they would rotate out their screens. And the answer to that really is relevant to the quality of the water, determining how much debris and how much impact you're having on that screen. A screen really is designed to last forever. It's the dirt and debris that you get into that screen and how often you have to clean that screen is what I would say relates to that question. I'd probably have a follow-up question back to say, are you referring more to how often you should clean, or how often you should rotate the screen? I don't believe if you got the right screen in there and it's built right, it should last forever. We have screens that have been in the ground and never been replaced for 20, 25 years.
Thank you. The next question is it a problem using smaller mesh micron filtration because of more frequent filter clogging? And how do you match the mesh and screen size to target contaminants?
Great question. This is all based on your emission devices. So when you look at your emission devices and you say, I'm just going to throw out an MP rotator, for example. If you look at an MP rotator, it will have in its spec sheet or data sheet what its micron rating is. Basically, what that means is how big of a micron or diameter, 3D diameter size of a part contaminant can be a problem for that emission device. I believe on the MP rotator it's 130 micron. I'm not 100% sure, but that's what I'm guesstimating. So you would want to build your system to filter anything 100 micron or 130 micron and above. So you would go just a step above that or just right in that range in order to protect your emission device.
Great, thank you. The next question is, how long do the batteries last on the controller?
Great question. We get that question often. This is somewhat contingent upon how often it's going to flush. The good news is that the solenoid that it enacts to cycle the flush is a DC latching solenoid, so it's not using a lot of power in order to activate that flush. Typically, depending upon, again, how clean the water is or how dirty the water is, will depend upon how often it flushes, will give you a kind of a timeline as to how often that thing will last or how long the battery will last. We found in history so far on the Mini Sigma, for example, it will last anywhere from 2,000 to 4,000 flushes, which, if you look at it, could be relevant to a 6-month period or a year period, depending upon how dirty your water is. So it's kind of a catch-22 question, really, but I would say that on average 2,000 to 4,000 flushes, and again, that's contingent upon your water quality.
Great, thank you. Is Mini Sigma available with disc screens? This is the next question.
No, it is not. It's a screen only. It's a suction scanner screen only.
And how do you prevent freezing?
Great question. So we have quite a few videos of shutdowns, so you can learn how to properly shut the system down for a freezing territory. And then we also recommend having a polar blanket or some sort of cover over it during the freezing times or seasonalities. So that is one way. Inside the ADIP, it does have a setting in there that is set for what we call it. It's not an antifreeze. It's called a setting that you would put it at a 32 degrees or 35 degrees. If it gets below that, it will cycle the flushes so that it will allow the water to keep moving through the filter instead of freezing up and locking over. So if but that's a short-term solution. We still recommend and tell everybody to watch the videos, understand how the proper shutdown is for the filter, because it will require that to prevent freezing.
Next question is, what is the range of pressure drop that occurs between the inlet and outlet of the different types and sizes of filters?
Okay, so that is a great question. It's pretty loaded. There's a lot of to do with that question in terms of the different filters. There's charts that we have that will measure those. Typically, every filter is only going to have about less than 1 psi differential through the filter for flow. But what we have, there's 2 different types of pressures. There's a standard pressure that has through the filter itself, and we keep that to where it's a minimal less than 1 psi drop. So it's not going to affect your system at all. During debris and contaminants getting into the filter, it actually will set that. We have a predetermined number that when the filter gets dirty, the inlet pressure will be more than the outlet pressure. And once that differential hits 7 psi, which is our preset number, it will flush the filter. And that's how it automatically flushes based on DPI is what we call it, inlet and outlet pressure differential.
Are all Amiot manual widescreen filters suitable to be installed on the main line subject to continuous pressure?
Yes.
And the second part, there's a second part of the question, which is there any condition where they should be installed downstream on the system control valve?
So the answer to that question is yes. All of them are able to be installed on the main POC or point of connection to a project. It is contingent upon pressure. So if you want to install an Amiot tagline on a system that has 120 PSI or a potential spike of 120 PSI, I would say no. I would say jump up to the Amiot black plastic and put that on your main line so that you're protected, because it is, again, I think they pointed that out, it is contingent upon pressure. As a second note, there are applications where you would install it downstream, and that would mean, those applications would mean that you have different filtration sizes or different filtration degrees that you want to protect different emission devices. For example, if you have one zone that's drip, that would be a different filtration degree that you would put on that as opposed to what you would do on a spray nozzle system. So you could filter the two different ones differently. But I still would recommend having something, if you're worried about downstream like that, I would still recommend having something on the POC as well, because you want to protect your valves. Because if valves get debris in there, they can cause problems as well.
Great, thank you. There are quite a few questions, which is great. And the next one is, there are times when I am designing for a low flow rate water supply. What is the lowest flow rate that the Mini Sigma needs for its flush?
Great question. Let me look at my book. Let me look. Actually, I have to find my other book. I'm not 100% sure. I'd have to look that up. And if that person is listening still, if they shoot me an email, I'll give them all the specifications on that. It's pretty low. We do have some that go down considerably on, and the Mini Sigma is that one that would meet it. There is a minimum on the flow though, and so we'd want to make sure we apply it correctly. And I'd be happy to send some information on that out.
Okay, great. The next question is, have you had any success in filtering out protozoa or bryozoans?
That's a great question. That's going to be one that I'll have to do some homework on to be sure I answer that correctly. I know we've had some really complex filtration designs that we've done. And I want to say that we probably have solutions for those things, but I would have to follow up with some of the guys that have done this a little longer than myself.
And
so
again,
if that person wants to shoot me an email as well, that's fine.
I was just going to say that. Okay. How do you prevent or eliminate organic suspended solids in the water in order to avoid clogging the filters?
Well, there's, that becomes a water treatment issue that you would do prior to filter. But the beauty of having a fully automated system is that we actually do deal with those suspended solids that get into the filter. If you have a manual filter, then you're going to deal with those, cleaning those and dealing with those constantly. If you have a fully automatic filter and those suspended solids are getting into the filter and clogging it, it will automatically clean those when that differential comes, so you won't have to worry about those as much. But there always is, there's a couple different ways to view this. When you have a pond or a surface water system that's creating algae, aerification, those things like that, moving the water can help those things, but that's a different topic, really. You can pre-screen those things before they get in, and then you can screen them through the filter itself will help that if I was to be looking at the project. But in order to really manage algae on the pond side, which is what I think the question relates to, it's a different topic that we'd have to go into, and something that is more of a chemical driven. But if you're just worried about that being filtered to the system, then I would recommend looking at an automatic system that would manage that for you, and you wouldn't have to worry as much.
There are quite a few questions about filters, and we're going to move on to the next one, which is, should an irrigation system depend on a single filter or multiple filters placed in the system?
I think that question also relates back to the questions that we were, that the individual asked about having filter on the POC or downstream. And again, it all is pending what your emission devices are and what your end goal is for that project. If you have, we've done systems where if you have a really dirty system, you could put one on the main POC in order to break down that debris so the valve don't get stuck with the contaminants. And then you would put one on after downstream so you can protect the emission devices even further. So that could be the case on any project.
I have a question about the installation of filters, which is, do filters always have to be installed above sprinkler heads?
No. There's no, they're not like a backflow. There's no requirement in terms of having them above a 12-inch raised of your highest head or anything like that. The reason I mentioned atmospheric break is because we want to be able to have atmospheric break between the discharge and any kind of backup that discharge would have. That has nothing to do with the elevation of the filter itself. So no, they could be lower, easy enough.
I have a question about the battery again. It's asking, can the system be run hardwired instead of through batteries?
Yes, it can be. It's very simple. We actually sell a conversion kit to be able to do that. So it's completely feasible to be connected hardwired. Yes.
Great. A lot of the questions are repeating the previous question. I think different people wrote the same questions at the same time. One of the questions is, how important is it to design in filters for everyday residents, landscape projects, especially since there are a lot of irrigation system sprinkler pop-up nozzles that convert to rotator type nozzles for water efficiency?
This kind of comes into your level of protection. Everybody has a different level of protection that they would desire in life, like insurance policies or life insurance policies. Filtration is not that much different from that. If it were me, I would be designing them into all systems for the simple fact of protection. Even on my own home, I have filters on my home and I'm on municipal water. And I do it for specific reasons. There's always going to be some sort of debris that gets into a system, no matter how clean I am, no matter how much a maintenance guy works to make sure that when he fixes a mainline break or something like that, there doesn't get any contaminants in there. But it's always a possibility. And what happens to that is if you get contaminants in there, specifically like to your valves or to your nozzles, those nozzles that are $5 a piece now because they are more efficient are harder to clean and make them reusable. So it's almost okay, take it out and throw it in the trash. Well, If I have my filter on there, I protect against that. I protect against the fact that down the road, I have to replace a nozzle. I put in a $30 filter or a $25 filter to protect me from having to replace $100 worth of nozzles down the road.
Thank you. We're out of time, but there was one question that I think we can go over just by a minute for you to answer. It is, are your product catalog specs available for download from your website?
Yes, they should be all on there. If there's more information you seek, email one of the team members and they will get you the information as quickly as possible.
Okay, great. As mentioned, we are out of time. Thank you for such an engaging webinar. Many people were very interested in your presentation, as shown by the numerous questions. And if we haven't gotten to your question yet, because there were some questions left unanswered, I will forward them to Ron and give him your contact information for him to respond. And if you think of a question later on that you haven't had time to type up yet, you can always email Ron directly. His email is shown on the screen right now, or you could email ia@education@irrigation.org. We will be happy to pass your question on. Thank you for attending, everyone. Don't forget to check out IA's website for upcoming webinars during the year. A big thank you to Ron for sharing his knowledge with us today and for such an engaging presentation. And thank you, Amniad, for sponsoring today's webinar. This concludes today's presentation. Thank you. Goodbye.